Thank you very much for joining today's webinar. My name is Boris Mamkin. I'm sales engineer with InterSystems Corporation, and I will be presenting today on the topic on how you can make your robot smarter by augmenting the device data that you're capturing with additional information. The feature use case that we'll be doing a live demo today deals with using Alexa Echo device for pain level capture. So all of you on the phone are already customers of InterSystems utilizing some pieces of our technology. It might be Cache for your database for the persistent layer. It might be Ensemble or Health Connect to provide the interoperability, business process orchestration. It might be any of the solutions from the HealthShare solution family. You might use the unified care record to aggregate data. You might use patient index to do the identity management. You might use Health Insight analytical solution to actually empower and getting the insights out of that data. As part of your business, I'm sure you're already connecting to the external systems which are available outside of, let's say, your particular application or solution. It might be a provider, payer, system like EMR, like Siemens, like NextGen. It might just happen that your solution acquires information from a variety of the sensor or the device platforms that can be as complicated as orthorobotics or implanted devices like glucometers or the insulin pumps to a consumer, let's say, hardware, the wearables. These are your Fitbits, the Apple Watches, the scales, and other devices. You possibly already provide the bidirectional communication from, the device streams into the EMRs, or you're aggregating that data in some form that provide value to your customers. The question is, what is next? And the answer that I would like to propose, right, as the key theme of today's webinar, that the next step into taking that data, aggregating the device data, or integrating the device data with the clinical data that you acquire from the EMR or the payer system, and marketing and monetizing that data using machine learning and augmented intelligence or artificial intelligence for that matter. What type of value you can derive by doing the high-level analysis on the integrated data set, the device data and the clinical data extracted from the EMR? The immediate response would be you can calculate the predictive risk, right? You can assess the risk and the common application of that particular modeling would be predicting the risk of the readmission, predicting a potential future cost when you discharge a patient with a particular clinical makeup. By integrating device data or augmenting your device data with the clinical information, you can determine the risk of the possible hospital-acquired infection. So if you're a device manufacturer, like in the field of endoscopy or orthopedic surgery, and you provide a sort of sensors that monitor the sterilization, or you provide certain artifacts or the devices that are dealing with the machinery that emits the sensor data, you can couple it with the clinical information for that particular patient, put it in a single information mass, and then apply a data science, the next generation computational logic, to derive a pretty fine-tuned predictive model that can correlate the frequency of the sterilization as one example, or potentially changes in the workflow on how devices are being handled with a particular clinical outcome. Based on that, you can improve the value that you provide to your customers, and ultimately, you can monetize that data. You can use creation of the predictive model and then surfacing those predictive model to your customer base as an additional service line, getting financial benefit from it. So once we're talking about connecting the sensor data, you collected already the data into a single environment. It is integrated. You define an artifact in the form of the predictive model. It's not enough just to do that. It needs to be exposed to an outside consumers, and not only it needs to be exposed to the outside consumers, potentially you need to have a pretty deep insight into who is consuming that data and how it is being consumed. This is where API management comes into play. Not only it can provide an IoT optimization layer where the different devices of the different types, shapes, and sizes can connect to your environment using REST, possibly FHIR, or other type of the API. You can monetize the data by understanding at what frequency, what type of users actually accepting it. In terms of the data marketing and the monetization, the clinical and the device integrated data sets or the predictive models which are derived from that integrated data set has tremendous value to the pharmaceutical, to life sciences, to the CRO organizations actually who are data hungry, and they need that data, or they need a set of the identified patient cohorts that can be defined using PMML or predictive models to drive their business. From our experience, a lot of the healthcare systems already driving that activity by hiring sales teams to actually identify the data that is meaningful for the external consumers, like pharma, like sciences, and they are they're defining the strategy or the methodology on how that data can be exposed for the consumption for the purpose of the data monetization or marketing. So what is InterSystems' answer to all of those requirements as a next step, right? Integrating the device data with a clinical data set, and then operating on it intelligently, defining a certain predictive risk models, and then exposing it to an outside consumers. The answer is Iris for Health. It is our next generation platform specifically geared for innovation that supports not only cloud deployment, and different modes of integration. It does allow for operationalization of those predictive models and supports the high-level analytical compute machinery natively within its environment. So I'm not going to read from this slide, just to some points that are relevant for today's conversation. If we're talking about consuming the device data, time series data, and it might be observational data or it can be telemetry that is being provided to Iris for Health, for example. The time series data, the device data is fast and it's big. Not necessarily from a single transaction perspective, but they're just going at a fast rate. So the horizontal scalability is a must. Iris for Health does give you that ability. We fully support sharding with the Iris for Health, where you can define a series of nodes. You can define a sharded cluster that has the ability to consume data at a very high rate, scale it based on the sharding key, and then present it to the consumers in a seamless manner. We do have an enterprise-grade API management that allows you to not only design different APIs and publish it using standards like Swagger, for example. It does allow you to monitor or to get insights from the API consumption traffic that is flowing through the system. In terms of the interoperability, for those of you who already has been using Ensemble or Health Connect for our integration or interoperability purposes, you do know that we fully support the standard-based interoperability, classic interoperability like HL7 V2. In addition to that, we have always been supporting a wide variety of the IHE protocols. Iris for Health going further, it actually brings you the client and both client and server FHIR support. So why it is important? On the server side, you can use InterSystems RS4Health file server to create a mini operational data stores where the data from a variety of data sources is coming in. It is being transformed and committed and persisted as a set of the file resources, and we do support DSTU2 and STU3. On the client side, if, let's say, you have a legacy, well, not a legacy, if you have an application with a bespoke API, it can be a REST API or the web service API, and you want to modernize it, you do have the ability to create, using our FHIR support on the client side, to create a FHIR layer that would essentially map your application, bespoke API into a FHIR standard. Workflow engine, notification delivery, all of that is important to driving action based on a particular trigger event that can be surfaced through the integrated, device and EMR data. Lastly, I want to spend few minutes talking about artificial intelligence and our support for analytics. InterSystems RS4Health does come with a set of the pre-built adapters that allow data scientists to interact with the data stored within RS4Health in a native environment that they're used to. One example would be the support for the native adapters for Click, Power BI, Tableau, where the information stored in the RS4Health in a relational form can be exposed to a data scientist through those tools using native adapters. If we're talking about a more intensive next-generation compute environment, we do provide a Spark adapter that does allow for parallel data ingestion into your ML compute environment that allows data scientists to operate on data extracts at a pretty high rate. So the featured use case is based on Cedars-Sinai pilot, where the Cedars-Sinai wanted to put Amazon Alexa device into each room, trying to alleviate some of the tasks that nursing personnel has to do, which is not related to patient care. One example would be, changing the channel, maybe pulling up the menu for lunch or for dinner. We use that as kind of our frame of reference, and the sales engineers inside InterSystems took that use case further and actually developed an Alexa skill that is capable of interacting with the patient and capturing their pain level. Now, the pain level capture is a standard protocol in the clinical care setting, especially if patient is in the recovery room, post-surgery or post-procedure. The nurse would come in and ask a series of questions to assess not only the pain level of the patient, but their cognitive ability. The nurse would ask their first name, last name, date of birth, and other questions which might not necessarily relate it to a condition of the patient, but again, those questions are needed to assess the patient's cognitive ability. That brings us to our demonstration. What I have in my office on my desk is Alexa Echo device with the skill InterSystems Alexa pain level capture skill enabled. I will play a role of the patient. I will play a role of Marla Gonzalez in the patient bed, going through the post-op recovery care, and I will record my pain level using Alexa. What we'll see typically once the pain level capture, it's not enough to capture the pain level using the device, right? Somebody needs to be notified typically that the particular trigger has occurred. What you see on your screen right now is our sales engineering Gmail inbox that I'm using as a proxy to capture that notification. So let's go through the demo. I'm launching my Alexa Echo. Alexa, run pain checklist.
Welcome. I am the InterSystems voice assistant. I will go through a simple checklist, and I will send your responses to your doctor. First, what is your first and last name?
Marla Gonzalez.
Thank you, Marla. Now, tell me the month. day, and the year of your date of birth.
September 22nd, 1972.
Next, on a 0 to 10 pain scale, tell me the intensity of your pain by saying 0 if you have no pain, or 10 if you need immediate assistance.
9.
Ouch. I will record your pain level as 9 and send for help right away. InterSystems will also examine your unified care record and let your doctors know of any related diagnosis or medication that might be causing your pain. Hope you feel better soon. Goodbye.
Thank you, Alexa. Goodbye. So, as you can see, as I was playing the role of the patient, as I was interacting with a robot, with a device, the care team already received a notification. So, not only Iris for Health was able to capture that and essentially route that particular trigger event to a care team to take action, you can see that this notification contains several information elements which go beyond just a routine notification of the particular, event. One element within this notification that we inferred that this particular pain reading might be relevant to the recent diagnosis of the chest pain. A second interesting element with this notification that we also included a predictive pain level of 8.13 within the next hour. So as you can see right now, we went already beyond from taking a reading, in our case, a pain level reading using Alexa device, which is innovating in itself, pushing it to our Iris for Health system, but we actually orchestrated a series of events where we enhanced that data with additional intelligence. One enhancement is, again, the association of the reading with recent diagnosis, and another one is the prediction in the future what that pain level might be. For example, if that patient will not receive their pain medication. So let's see what's happening under the covers. What I'm showing you right now is a production configuration page that outlines all of the components within the pipeline that power that interaction. This instance of Iris for Health is running on EC2 instance inside AWS, and it has a set of the adapters or components within that pipeline. So the post service accepts that post transaction with the pain level capture by Alexa. It forwards it to a message router where the message is qualified. The message router forwards it to a business process layer, which drives several events, orchestration events. Number one, we're reaching out to an external system to get a complete patient record information. Essentially, we're pulling the patient chart. We are also sending this augmented information against the operationalized predictive model to get our future, pain level prediction inside an hour. So let's go through forensics and actually see what the message trace looks like. In the first interaction right here, as you can see, even though we're sending in, a JSON payload from the Alexa skill, we're transforming it into a valid HL7 transaction, already associating a particular transaction with the patient ID. Now, this association can be achieved using our API management tooling that is included with Iris for Health. Once the message received by the router, we qualify this message, and again, the routing rules go pretty deep in terms of what type of information is being captured for auditing or troubleshooting purposes. The routing process determines that this particular transaction coming from this particular device, or rather pipe, inbound pipe, needs to be sent to a business process that orchestrates a series of events. In this particular case, we're using an associated patient ID to retrieve the patient chart from an external system. And in this particular case, we're interacting with the outside instance of the HealthShare Unified Care Records, and what we're getting back is the entire representation of the patient chart in the form some of you might already be familiar with. This is our canonical messaging format called summary document architecture. Does it have to be HealthShare? Absolutely not. It can be an Epic instance, it can be a Cerner instance, or it can be any other device. Do you really need to interact with it using our proprietary API? Again, the answer to that question is no. The interaction, this might be a FHIR request or a series of FHIR requests where you're getting the entire patient bundle out. It can be an IHE XDSB on XCA type of interaction where an entire patient chart is being pulled back in the form of the CDA document. Or it can be a custom API, which is specific to a unified care record that you're integrating with. So right now, we already have the pain level captured. We have the extended, patient information. We pulled the patient chart. The next step is to actually bounce it against our operationalized predictive model. And in the later stages, we'll go deeper into what that machinery looks like. So we're assigning the day, the hour, the minute, the month, and the second, and the year, right? That's our feature vector that we're sending into our predictive model. What we're getting the response is the prediction that within the hour, this patient pain level will be of this, that would be that value. As you have seen, in addition, we're discharging or we're dispatching the email alert notification to the team stating, again, with enhanced information on the inference of that particular pain level with a potential diagnosis and the future reading and the current pain level. So in itself, can you orchestrate the notification to a care team using a reading from the device? The answer is yes. Can you integrate the device data and the clinical data into a single kind of runtime environment? The answer is yes. Can you expose that data to the predictive model, and can you define a linear regression that can do the prediction of the pain level in an hour? The answer is yes. Where Iris for Health is different, that it gives you the capability to do all of that within the single runtime, completely separating the different streams, API design, the data scientist work, but all of that converges within the single runtime artifact, in this particular case, Iris for Health production powering all of the capability. Moving on, let's actually take a closer look at our pipeline configuration. This particular post service, it is a custom RESTful service that sales engineers have implemented. One point of interest here is essentially how we treat the JSON payload, the JSON stream data coming from Alexa device. InterSystems Iris for Health does give you the ability to consume JSON payload of variable complexity, and we have a built-in tooling that allows you to generate a valid dynamic object script object, and I guess I'm repeating myself in that statement, but once you serialize or re-express the JSON payload into dynamic object, now you can actually, inside our runtime, you can programmatically access the object properties mapped from your JSON payload and create a valid HL7 transaction. We also have the ability, because it is coming through the device, and we use the API management tooling to associate that particular device with the patient ID based on the location on the actual patient, like a REAS tag. Another interesting point that's worth looking into more deeply here is the orchestration layer, right? The business process definition. As you can see, we're consuming the data, and we have certain context variables which are defined, but the real interesting step is this one, where we're taking the pain level captured by the device and submitted into Iris for Health, and we're essentially creating a minimal operational data store, or the data mart, within the same runtime as a separate data structure that can be used in the later discovery. So as we're inserting populating the data, here, this is where we're making a call to an external system. This is where we're checking for the pain, and this is where we're making the pain inference. Now, right now, it can be coded, but it can be a call to an external terminology system, for example, that can provide a more robust, ontology for making inference. Let's take a look at our minimalistic data store, the operational data store. The pain level capture, it's right here, a SQL interface that also comes with Iris for Health. Here, all of the readings that have been captured and granted. This demo is very popular against our sales engineers inside InterSystems, so we actually show this demo a lot. And as you can see, sales engineers also like the pain level readings of 8 or higher to get that ouch sentiment back from Alexa. So that's why you see that high readings here. So once this information is staged, you can expose it to your data scientist using their own tooling. So an example of what that data scientist discovery process would be is connecting your Zeppelin notebook to a cloud-based instance of Iris for Health, to that particular data mart, for the purpose of creation a linear regression model. And that's exactly, this notebook contains those steps where we're fetching data from our Iris database, and this is essentially a table or the data frame that is being extracted from my cloud-based instance of Iris for Health. This is where we're staging this data locally in Zeppelin. You can optionally, the data scientist can optionally graph that data now using the local representation of the Iris's, stored data in their local environment. This is where we're defining a set of the feature vectors. In our case, we're using the time-bound features of the data that we're storing, year, month, day, hour, minute. This is where we're training and creating our data model based on the linear regression algorithm. This is where we derive the statistical metrics of that model. Optionally, we're applying this model again to the data set, which is local to my machine ML environment. That's just an extra step. You can optionally visualizing it. But here is the crucial thing, right? So now, as a data scientist, I'm relying I have relied on the InterSystems Iris for Health for getting the data in. I have used my local environment to get to the data, operate on the data, create the predictive model. Now I need to operationalize it. Now, again, within a particular ML environment, Zeppelin is one example, or even Spark, or any other technology, you need to bring it back where the data is being processed or where the data lives. In this particular case, I'm exporting my predictive linear regression predictive model in the PMML format. Well, PMML stands for Predictive Markup Modeling Language. That's a standard that a lot of the data scientific tools use to actually express the models which are derived within their runtime for the external consumption. Once the data is, once the PMML model has created and is being exported, it can be brought back into Iris for Health runtime. Now, what that PMML model looks like, essentially, it's an XML block defining the data dictionary, the regression model, and the inputs and the outputs, similar to a schema. Now, what happens once you import it into Iris for Health? Our machinery, our analytics, or specifically PMML machinery, does multiple things to make your life easier as a consumer of that model. Number one, by consuming the definition, we're actually creating an internal runtime representation of that model with all of the properties which are needed. In our case, that's the feature vector associated at PMML data types within our environment. We create a regression model input that can be used for messaging, right? We we're creating the output that would be a response on how we can capture a response from executing our predictive model. This is the actual predictive model runtime, and more importantly, this is the business operation, right? That artifact that is being used in our data pipeline that can be added to the production definition pacer, the pipeline that will use the inputs and the outputs generated through a simple import of the PMML structure. Now, as you can see, the only thing that you need is a valid PMML model. Once you bring it in, all of the other things which are needed to bootstrap it inside a data pipeline already generated. Going back to our to the deck, right? Let's break down the actors. So, if I am to use a single slide to depict the use case, I would use this, right? There is a unified care record. It can be HealthShare, it can be Epic, it can be Cerner, it can be NextGen, any other system which consumes the data from, an EMR systems. It can be a single EMR, it can be multiple EMRs. It's irrelevant. What is relevant that it has a way to expose that clinical data using standard or non-standard means to Iris for Health. Iris for Health is a gateway where the device data is being consumed. Now, the device data, it can be an observational data, right? It can be, in our use case, it was a pain level that has been captured, but it can be an insulin reading from a glucometer, or it can be embedded insulin pump that just administered, an insulin injection to a patient. So those observational or procedural data can find its place into Iris for Health. You can drive notification from it. More importantly, the device data can be of other sorts. So it can be the data relevant to the device state. Now, by creating or capturing the device state data and the observational data related to the patient and actually reaching out to the unified care record and exporting or extracting the clinical information, now you have an ecosystem, a data ecosystem, that allows you to define that predictive model and then bring it back to operationalize it, to drive a variety of the services that can be provided back to the consumers. So connectivity. As I mentioned, API management is a cornerstone in any device-based connectivity. The API management allows you to design, define, and then essentially monitor the utilization and the traffic that the external system used to get to the data residing within your solution powered by Iris for Health. Microservices, web services, the publisher, the developer portal, the gateway that does the API lifecycle management, the runtime deployment, authentication, authorization, the traffic control like throttling or canary testing. All of that is provided by InterSystems API management inside Iris for Health runtime. Now, one of the key aspects, and I'm sure some of you already have a question, well, I have an Alexa, which is an external device, right, sitting in the patient room. What would the exact steps be by which a particular device serial number or device ID would be associated with a patient identity? And again, with help of API management, these are the high-level steps, right, that actually empower that correlation. So each device, is provisioned with a unique device ID. In many cases, it's a serial number, but it also has an API key. Now, once you place that device, it can be a hospital room, it can be associated with a bed. Once you activate the device communicates with our API management gateway with API key and device ID. And this is where the API management can actually do can use the external system to enable that correlation or that linking, that this device really correlates with this particular medical record number or the enterprise ID. I think in terms of once you're connected, again, you want to, API management allows you to do the operational reporting on the devices itself. So for example, because all of the devices are already passively or actively connected to the API management, you do have their ability to control or to essentially assess which devices are more busy, which devices are carrying more load. More importantly, you can identify that this device actually went offline and do a proactive notifications, for example, to a biomedical engineering team to get that particular ward of the nursing floor or that particular room to either swap the device or fix the device. The IoT device data, the storage, scalability. We have been providing, the vertical and the horizontal scalability for decades already, right? In terms of vertical scalability, the parallel execution of the SQL or optimizations to our, storage, the global module, every release of our technology has a performance improvement in it. In terms of horizontal scalability, again, some of you might be familiar with the enterprise cache protocol, where you have a single database server which shares its cache with multiple app servers sitting on top of it, scaling essentially the user load, where we bring data to the compute. Now, Iris for Health has a new feature in it. It's horizontal scalability, but horizontal data capability, also known as sharding. So in this particular case, not only you can scale the user workload, right, using enterprise cache protocol, we use the same technology, the same ECP to enable what we call intelligent inter-shard communication, where the data can be partitioned amongst multiple data shards, providing the support for a hybrid kind of workload. In this particular case, a system configured like that can support a pretty high ingestion rate, reading the data writing the data into, let's say, a sharded cluster in parallel, reading the data from the same table. A few weeks ago, I've done the demo on my local laptop, specifically for the demo was geared towards the support of that hybrid workload, and I have achieved a sustained 150,000 records, inserts into the database, doing, reading from it at the same time. So it's pretty interesting. I think, that's the statistics that proves my claim. These are the results of the benchmark that have been run by a third party. The customer is not a healthcare customer. It's actually an investment, one of the leading investment banks. As you can see from the graph and from the tabulated data, InterSystems Iris operated on 10 times more data than our competition. And the competition in this case was in-memory or the custom columnar store databases requiring big iron. Not only we were operating on 10 times more data and essentially utilized much better performance than the competition, we were doing it on less power hardware without any outages. So in itself, I hope that is the sufficient proof that our performance or the sharding capabilities actually are beyond what our competition brings to the table. So analytics. In the demo, we ran a predictive model, a linear regression model on pain based on time. But in reality, there is nothing that, again, would prevent you from incorporating the clinical data or the device operational state data into your data model. So what would be the potential data sources? Non-clinical data, those the financials, the public registries, it can be an EMR or any other file repositories. More importantly, unstructured data. Iris for Health does have an NLP engine built in. which uses a bottom-up indexing approach for indexing or parsing or ingesting unstructured content, which is not dependent on any existing ontology. We actually use linguistical data models to identify the boundaries within the text, which are semantically meaningful. That makes it fast, that makes it efficient. More importantly, it actually sits within the same runtime. So in terms of high-level data flow, using that powers the predictive analytics by InterSystems Iris. Iris in itself is a data capture or the data staging asset, if you will. It can consume data at a very high rate, as I was already outlined, but more importantly, it actually can provide the sample output or the testing that data to next generation compute, right, the machine learning environment where the data scientists define their models, they do their feature vector engineering, and they define the actual model. Now, once the model is defined, to operationalize it, InterSystems Iris for Health can consume the PMML model and bring it back in using the machinery that I showed you in the live demo, where that model can be applied on the data both retrospectively that already resides within our database or to the new data as it flows through the system. The Apache Spark, if anybody wants to play nice in the ML AI world, they do need to have their ability to support Spark. We do have Apache Spark adapter that supports essentially what the data scientists expect of any Spark, functionality, right? The predicate push down and other optimization enabling very high read and write rates. We provide that. The predictive analytics, the PMML producers, right? Virtually every commercial or the open source vendor does support the PMML, does support the export of the particular model defined inside their custom, bespoke runtime through a PMML definition. That actually allows you to fully separate the model producers from the consumers. So if you are to adopt an InterSystems Iris for Health inside your organization for the purpose of the data science, rest assured that the adoption of the Iris for Health, because you're using PMML, completely separates the model producers from consumers. So the introduction of the Iris for Health is non-disruptive to a data scientist flow. What type of predictive models are supported? I gave you an example of the linear regression. There are other ones that are supported, and here is the list, like neural networks, K-means clustering, the vector machines, and others. And we're actually our product team is working on enhancing that list. We're at the end of our presentation. I hope it was meaningful. I hope that I managed to interest you in the topic, how you can use Iris for Health to power the data analysis on your potential devices augmented with the clinical data. If any of the topics that we covered during today's webinar are of interest to you, please reach out to your InterSystems account team. Right now, I will open the floor for Q&A, so if anybody has questions, let's answer them. All right, so one question. eShard processing available to be applied to Streamlit data stores within the health share. We have large ECRs that we would love to split to smaller segments. Good question. Right now, well, the next version of HealthShare, I think, 29, I don't want to call the version, but the HealthShare team is in the process of migrating HealthShare runtime into Iris data platform. In terms of will sharding be supported on the edge gateways, eventually it might. not in the immediate future. The reason for that being that our sharding capabilities are SQL bound, so you can only shard relational data. Because the Streamlit databases are not relational in nature, it would probably take some time. One thing that I do want to mention that we have done few experiments where we actually put the health insight source tables, right, the relational tables, onto Iris for Health, and we were able to shard it. And the querying time has been reduced dramatically. If you want to get more information on that particular experiment where Health Insight data model was sharded, please send me an email or reach out to your InterSystems account team. Second question that I have is, how was HIPAA satisfied with the use of Alexa? Well, HIPAA is always a loaded subject. So I think right now, I'm not sure if you heard or not, but Alexa in itself has been certified as a HIPAA device. The skill that we have developed, we did not put into production use. Again, that particular demo was developed to showcase the point in a rather interactive or innovative way on how a user might interact with a robot and how that robot might push that data upstream to the cloud instance of Iris for Health that can be augmented and will be used to drive additional, notification workflow augmented with prediction or additional assets into it. Are there any other questions? If not, we're at the end of our webinar. Thank you very much for your time, for your attention, and have a good rest of the day. Thank you. Bye-bye.